Okay, so this is week 11. So we look into another model. This is what we call association basic concept, normally used by people in marketing or in economy to look into the buying pattern or purchasing pattern by customer in supermarket. So based on the finding that they get from this, they can strategize their marketing or their business in order to improve the sales of the product. Okay, so what is this association rules or basic concept? So we look into this. Okay, like I mentioned just now, this is normally used in trying to find pattern in supermarket purchasing behavior. So given a set of transaction, they will find rules that will predict the occurrence of an item based on the occurrence of other item. So for instance, in this example, we have the diaper. So whenever you buy diaper, you also buy beer. Okay, maybe stress. Or if you buy beer and bread, the person also buy milk. Okay, so we have what we call X and Y here. So Y is dependent on the X that we have. So this can be derived based on your market basket analysis. So this is market basket transaction where you do not have equal number of item per transaction. So if you look at each of the TID, we don't have enough, we don't have equal number of items for each of the row. Okay, so what we want to predict is we want to predict the Y here based on the occurrence of the X here. Okay, so let's go for some definition for frequent item set. So given this is the transaction that we have, so item set can be defined as a collection of one or more item. So item set, this is what we call item set. Each transaction can be considered as one item set. Okay, so over here we have 5. So this is the example that we have. This is the item set. If we are referring to K item set, so which means that we have K number of item we have. So for instance, if we have 3 item set. Okay, so that means we have 3 item in the set that we are talking about. If we have 5, we have 5 items. Okay, so that is the definition of K item set. We also have this support count. The support count refer to the frequency of occurrence of an item set. So for instance, if you have this item set, how many times they exist in the transaction? Okay. So in this, for this one, we have 2 because this 3 item set exists 2 times. For instance, milk, bread, diaper. 1 and 2. So they exist 2 times. 2 times here. Okay. So that is what we call support count. Okay. We have count. We count the number of time that the item set exists in the transaction. Okay. For this one, how many? What is the K? Can you type? what is K here? K refers to the number of item, right? So how many item we have? 3, right? So this is 3 item set. We have another definition which we call support. Support refers to the fraction of transaction that contain an item set. So this is referring to the fraction. So for this one, we have the support count equal to 2, right? So 2 out of 5. So 2 out of 5 here. So the support refer to the percentage of occurrence of this K item set that we have. So count just give you the number of row, and support will give you the fraction of transaction that contain that particular item set. So in this case, we have 2 over 5. Okay. So this is very important because you will, the whole idea is you want to find pattern, frequent pattern, right? So we have to look at which K item set that has the highest support. Okay, the highest support means they have high frequency in the data set that you have. We also have another one. So we define this frequent item set, an item set whose support is greater than or equal to the minimum support threshold. So this one is defined by us. So for instance, if we say the occurrence of the item set must be at least 3, so at least 3, so this is not frequent. But if we say, okay, my minimum support threshold is 2, so that means this K item set is frequent. So the frequent item set is highly dependent on the minimum support threshold. So this is set by us. So in order to define the association rules, we have to look, or we have to use some of the formula that we have defined before. So we have to use the support. We also have to use another formula, which is the confidence. Okay, let's go and look into that. So when we say association rules, it refers to an implication expression of the form X going to Y, where X and Y are item set. For instance, we have this X comprises of milk and diaper, and your Y is beer. Okay. So in order for us to determine whether they are frequent or not, we have to look at the support. So what is the support that we have here? So the support here referring to the fraction of transaction that contain both X and Y. Okay, so going back to the previous example here, so we are using this support. Okay, so in this example, if we use this, so the support for this is 2 over 5 because we have 2 rows here consisting this 3 item set over 5 rows. Okay, so we have that support. We also have this confidence. Okay, this confidence measure how often item in Y appear in transaction that contain X. So we can define this one. For instance, this is the rule that we have. So we have X and Y. This is X, this is Y. Okay, so we consider this one as 3 item set. Okay, three item set because we have three items there. Okay, so if we look at the support for these three item set, milk, diaper, and beer. So this is one, and the other one is this. Okay, so we have two. Okay, the support is two. The support count is two, and the support should be 2/5 because support give you the fraction of transaction that contain both X and Y. So in this case, we have 2/5. Okay. Okay, but the confidence tell you measure how often item in Y appear in transaction that contain X. So we take this support here, and we only take the X that we have. So this is your X. We count the number of X. So this is 3. So what we are trying to say here is that because we say, okay, X going to Y, and we have, in this example, we have 3 item set. Okay. Divide by X because we want to know what fraction of the transaction that we have that will allow us to have this. So in this example, we have 2/3. So the confidence, if we have 3/3, that means the confidence is high. All the pattern that we have, we can capture for all of the row that we have. Okay. So these two formula that we have, support and confidence, will be used to extract which rules are important to the whole transaction that can be used as a guidance to the supermarket how to arrange them. For instance, they can put all of them near to each other, okay? Or they can bundle up the one that is not popular with the popular item. So that's why sometimes we go to the supermarket and we end up buying things that are not necessary because they are bundled up together. Okay. Okay, we also have another one. So we can use support or we can use confidence in order to filter the rules. And the third one is called the leaf. If you look at the leaf here, the formula here, they are looking into the variation when we have both item A and B, or if we separate them from each other. So the leaf is a key matrix in association rules that measure the strength of the association rules by comparing the observed support of the rules. Okay, this is your rules. You want to compare if they are together with if they are separately computed. Okay, so we are comparing and the observed support of the rule to the expected support if the antecedent and consequent were independent. So if the leaf is 1, that means these two are the same, right? Your antecedent and consequent are the same, this and this. So the aim is if you have the value of 1, you have better rules. Okay, so this is derived from the support that we have. But the task is now is how do we form the formula here? How do we form this formula? This formula. How do we form this? Because there are so many ways on how we can form the formula that we have here. Okay, so it goes to the frequent term set again. So we go back to the frequent term set. So that means we will highly depends on what is the minimum support value or threshold that we set. Okay, so it all goes back to the minimum support threshold. It all goes to the minimum confidence. So if we set this minimum support too high, or the confidence is too high, then you will have less rules, meaning you really filter them. Okay, but if you set this one too low, you will have so many rules that you don't know which one is more important. So finding the optimum values for minimum support and minimum confidence is another study. But in this class, we just set the minimum support to be 2 or 3, and we see how it looks like. What are the rules that we can get from these values? Okay, are you following me? If you're okay, can you type number 2? Okay, so thank you. So when we have in mind what is the minimum support threshold and minimum confidence, normally we only set this one. Only set this one, okay? Okay, we could find the rules by using brute force. Brute force is a definition in which we try all the combination. So we will list all the possible combination, and we will look at individual rules that can be derived from the combination. For instance, if we have A, B, C, this is 3-item set, right? So we could have A going to BC, and then B going to AC, and then C going to AB, and this is only one. Then we go to AB going to C, and then AC going to B, and then BC going to A. Okay, so we have so many combinations here. So the brute force approach is to try every pair of combination, but this one is very, very time consuming. Okay, so what can we do? Okay, before we go further, we want to look into some of the things that we have here. For instance, this is the 3-item set that we have, right? So this is the possible combination of k item set we have. In this case, this is 3. Okay. Oh. So this is we have the milk, we have diaper, and we have beer. So from this milk, diaper, beer, we can form all these in rules. We just change the order, which belong to X and Y. Okay. So if you look at the support here, the support here remain the same, but the confidence will be varies because of we only look into the X here. Okay, so if we look back at the confidence here, so your confidence is highly dependent on your X, which is this one. So that's why if we look at here, so your confidence is highly dependent on your X only. Okay, they count the number of rows that consisting of this X. Okay, so for the same K item set, you will see the same support, but for the confidence, you will have various number because it all depends on the X, on the occurrence of item in X variable only. Okay, so these are the three observation. All the above rows are binary partition of the same item set. So basically, all the rules that we have here coming from these three item set. So this is all the rules that we have. Possible rules. Okay, rules originating from the same item set have identical support. So you have the same support here. But they will have different confidence depending on the occurrence of the X value. Okay, so that is the observation. And as you can see, when you want to find the rules, you have to list all the possible combination, right? So this is very time consuming. So they have designed a method on how to prune, how to do the shortcut. Okay, so this is what we call the a priori algorithm. Okay, so what we can do here is that there are two steps here. So in the frequent atom set generation, we generate all atom set whose support which is greater or equal to the minimum support that we have. So this is determined by us. So this is set by the user. Okay. So based on this frequent atom set, then we can look at the rules that has high confidence. Okay. So remember that we look into the frequent atom set first, then we filter using the confidence. Okay, let's go to this diagram here. Okay, so basically, if you have three K item set, so if you have K item set, so basically you have K to the power of no, yeah. If you have K item set, so that means we will have 2 to the power of K combination. For instance, if we have 3, K equal to 3, so we will have 2 to the power of 3, which is 8 number of combination. Okay. So in this example, we have 5. So we have 5 unique items that we have. So the K equal to 5 here. So the number of combinations should be 2 to the power of 5. So 2 to the power of 5 is equivalent to, 32, right? So this is including the empty set and the full set here. Okay, so we will use this in order to find the frequent item set. Okay, so we will start here and then go down. So these are all the possible combinations. Okay, if we find that this is not frequent, this is not frequent, so we can cancel all this thing because we don't have to go down more if we find that this is not frequent. Okay, because the computation is very high. If you look at here, the number of transactions refer to N here, W refer to the size of your item set, and you will have list of candidates here, M, which is 2 to the power of D. The D here refer to the number of unique items that we have, right? So the complexity is very, very high. You have to count the number of the occurrence of all the combination here. So another way to avoid this is when we have something up, we go here. So if we have AB found to be infrequent means not frequent, means less than the minimum support value. So we don't have to go through this path. We avoid that. We don't need to go that further direction, go down here. So basically we have eliminate some of the unnecessary calculation. Okay. Let me go back. Okay, in the when we try to reduce the number of candidates here, so by looking at this diagram, this is very easy because if we found that this is not frequent, we will start from here and then we will start individual and then we start the combination and go down. Okay, so once we found this is not frequent, so we don't have to go down again. So this is based on this definition in which it says that for all x and y, if the x, let me see. Okay, so we are looking into the support of x and y here. This is the support x and y. So if x is a subset of y, so the support of x must be greater than the y, right? So if this is not frequent, we don't have to go down more because x is a subset of y. If we go back to here, this AB is a subset of ABC, right? If we found that the support of this, the support of AB is always higher than the support of ABC, because the more item you put in, the less support you will have because you have more items. Okay, so based on that assumption, let's say if this is not frequent, this is no more frequent anymore because the support of AB is always higher than the support of its subset. No, to its superset, because AB is a subset of ABC, ABD, and ABE. So that's what it meant here. So based on this assumption, we can ignore the rest when we found that this is not frequent. Okay, let's take a look. How do we illustrate this one? Okay, this is your transaction. We set the minimum support to be 3. Okay, now we have to list all the one item set. We always start with one item set because here, so we start with all one item set. So this is k equal to 1. This is k equal to 2. This is k equal to 3. This is k equal to 4, k equal to 5. Okay, so we always start with k equal to 1. Okay, so we count for one item set. So for each one of them, we list how many rows that we can get for each of the item that we have. So bread occur in 4 rows. Okay, so that's why it's 4. Coke is only twice, so 2. Okay, so since the Coke and the egg is less than the minimum support here, then we will ignore that one for the next phase because there is no point continuing from there. We only take the one that is frequent. Okay, so what is frequent here? So we will take this and this and this. Also, we will take beer and this, and lastly this one. So these are the combination that we have. Okay, so we're supposed to have 6. So these are the 6 that we have. Okay, so this is two item set. Okay, and again we count the number of rows that they have for the transaction, the whole transaction. So we have this. So for this one, no need to generate more because they are not they are less than the minimum support. Okay, so next one we will continue with. Okay, we go with this. So which is bread, milk, leper. Bread, milk, leper. So we have 3 here. We continue this one with this, so which is the same. So we continue this and this. So this is bread, but this is four item set. Okay. So we use this and this. So this is similar. Bread and this similar also. Okay. So we have here. So since we only have 1 rows here, so there is no more combination that we can get. Okay. Any question on this? If you are okay, can you tap number 4? Okay, so we have another example here. So we have the database here. So we look into here. Okay, so for this one, the minimum support is 2. So we define this one, the minimum support is 2. Okay, so the first scan is just looking into the individual item set we have. So we count the number of rows. So we eliminate this. So we are left with this. Okay. Now we proceed with 2 item set. So we will generate all the possible combination here. So we will have this and this. So AB and then AC and then AE. So we have all this combination. Okay. If you have AE and EA, they are the same. Okay. So we have 6 here. So for each one of these, we count the number of rows that they have. So we have to eliminate this. So we are left with this. Okay. So from here, we combine again A, B, C. Okay. A, B, C, and then A, B, E, and then B, C, E. Okay. So for this one, at the end, we have this. Okay, so this is the 3 item set that we have. So for 1 item set, we have this. Let me erase first. All. So be careful in the exam. So this is your 1 item set. This is your two item set. Two item set. This is your 3 item set. Okay. Sorry. This is your candidate for 2 item set. This is your candidate. Okay, this is only your candidate. So this is the actual 2 item set frequent 2 item set. This is the frequent 1 item set. This is the frequent 2 item set, and this is the frequent 3 item set. So in the exam, I may ask you find all the frequent item set. So which consists of 1, 2, 3, 4, and so on. So you will have to continue until there is no more combination that you can get. Okay. Okay. Any question? Okay. For this, I will stop the class today. We will go for another example for this, which is the practical part. How do we actually use this if we are given the actual data set? Okay, so we will continue that one next week. For the time being, we will stop here.